Hey guys, welcome back to my channel. Today we'll be solving this question, the integral of x plus sine x upon 1 plus cos x dx. So let's begin. So, if the question was 1 plus cos x upon x plus sine x, the answer would simply be log of x plus sine x because we would have the differentiation of the denominator in the numerator. But here it's the opposite. We have the differentiation of the numerator in the denominator, which is why we'll be solving this question by parts. But first of all, I'm going to be substituting sine x as 2 sine x by 2 cos x by 2 using the double angle formula for sine x. And we know that cos x can be written as cos square x by 2 minus sine square x by 2 using the double angle formula for cos x or the half angle formula. We also know that sine square x by 2 plus cos square x by 2 is 1. So I can substitute sine square x by 2 with 1 minus cos square x by 2. So I can write cos x as cos square x by 2 minus 1 plus cos square x by 2. So 1 plus cos x can be written as 2 cos square x by 2. And now we're going to be substituting this and this in our original integral. So this becomes the integral of x plus 2 sine x by 2 cos x by 2 upon 2 cos square x by 2 dx. And now I can write this as two separate integrals. The first integral being x upon 2 cos square x by 2, and the second integral will be the integral of 2 sine x by 2 cos x by 2 upon 2 cos square x by 2. We can cancel the 2's and we can cancel one of the cos. So this becomes sine by cos, which is tan x by 2. So I'm going to place 1 by cos square x by 2 as secant square x by 2, and I'm going to take 1 by 2 outside the integral. So this becomes 1 by 2 and the integral of x secant square x by 2 plus the integral of tan x by 2. This is what we are going to finally solve. So now we're going to be solving the first integral by parts. We're going to leave the second integral as it is for now. So using the LIATE rule, I'm going to be placing x as u and v will be secant square x by 2. If you're not quite sure on how to use the LIATE rule or the by parts formula, you can check out my video in which I've explained it. I'll be linking it in the description box below. Okay, so now let's use the by parts formula. 1 by 2 still remains outside, and we have u into the integral of v dx. So x into the integral of secant square x by 2 minus the integral of differentiation of u into the integration of v dx. And the second integral remains as it is. Right? Okay, so now we have 1 by 2. The integral of secant square is tan, and since we have x by 2, the coefficient of x is 1 by 2, which will go in the denominator. So we have x tan x by 2 upon the coefficient of x, which is 1 by 2, minus the integral of, we're going to add a c over here because we just integrated. Whenever we integrate something, we add a constant. So we did plus c minus the differentiation of x with respect to itself is 1, and the integration of secant square is once again tan x by 2 upon 1 by 2. So this becomes 1 into tan x by 2 upon 1 by 2 plus the integral of tan x by 2. So now I'm going to open this bracket. So 1 by 2 cancels out because here 1 by 2 can be said to be in the numerator. Or I can write it this way, 1 by 2 into 2x tan x by 2 by taking this in the numerator. Minus, again I'm going to take 1 by 2 outside of the integral and I'm going to take it in the numerator because in the denominator we have a fraction, so it becomes the reciprocal. And we also have to multiply this 1 by 2 with this term. So it becomes 1 by 2 into 2 integral of tan x by 2 dx plus tan x by 2 dx. Okay, so the 2 cancels out and we are left with x tan x by 2 plus c minus, again the 2 cancels out, so minus the integral of tan x by 2 plus the integral of tan x by 2. So we have the same integral with opposite signs, which means they cancel out. And since we have no other integral term left, this is our final answer. So our final answer is x tan x by 2 plus c. Okay, so that's it for today, guys. Thank you so much for watching. I'll see you in the next video. Bye.